Hello, my fellow YouTubers. This is Roy back again. This is a fun little experiment I want to run with you guys. Working on some lathe weights, levitation devices, linear motors, and it got me thinking about the Bedini in a DC pulse. Lathe weight, he used a AC in his coils, and he was able to float aluminum above electromagnetic field, a moving electromagnetic field. So he called it the electric river. And I figure I'm going to dig deep. I'm going to go into the Bedini coil as far as using the circuitry. Right now I have one coil set up as a bifilar. I got it hooked up to the frequency meter, so it'll tell me a frequency. And for right now, let's bring over the freq meter, and we'll put it right here, I think. Let's see, can you see that? Is that too bright? 0 hertz. So we don't have the coil running yet, and we're not going to have a core in it. And we're running it with a 12-volt battery. And this light that comes on right here is the back EMF of the 2N3055. It'll be between the base and the emitter. The back EMF is on that. So right now we're going to first take this magnet, and that's how we're going to start it. We're going to stick the magnet in there, and you'll see a light come on over here when it's on. So I'm going to drop the magnet down it. Listen to it squeak, watch. All right, so it's on. The light's on. And right now, frequency, we're at 1.690 kilohertz. So that's the frequency of this coil. And it started with a magnet. Alrighty, cool stuff, right? So right now we have this 2N3055 set up as a Bedini. It is on and activated through this bifilar. The back EMF of that light is on the from the back EMF, so the transistor don't burn out, and it's between the base and the emitter. Now, so in Lathwaite's work, he takes electromagnetic fields, and right now, obviously, it's on, so there's got to be an electromagnetic field around this coil. So let me hunt down a compass, which I just found. Let me check the compass to make sure it's right, which it is. So we're going to take the compass and we're going to hold it up to it. So we're presenting a north up top. And what I'm going to do is take this neodymium magnet over here. Okay, and we're going to look for the north, which is right there. You guys see that? So there's the north. And that means when I take the north part of this magnet and put it down into that coil, it should repel it a little bit. I want you to hear how the coil sounds when I put this in here. and it's sitting on top of it right now like it's levitating. It's floating. All right, so it's switching, and it's at 1.656 kilohertz switching, and it's creating a magnetic pole, and it's also repelling the north. And now it just turned off. So it sucked it down and turned it off. Now this is very interesting too. I want you to watch this. Wrong pole. Let's turn it over. So we want the south heading down instead of north. Ready? Turn it over. I know it's doing it. See, the two springs of the, I'm calling them springs, but the tuning forks. I'm going to back them up so they're towards the end. Gives everything a little more spring. Let's see if we can get it running better. Ready? Didn't like that. Let's step it up to 24 volts and see what kind of reaction. That was 12 volts. Call it a self-starter. This is crazy. Look, a car battery and an alarm battery, and we're just going to connect the 24 volts. Crap, and it's a self-starter, guys. back EMF. Uh-oh. Let's try it again. Neodymium magnet. I was getting ready to take you over to the frequency. It says we're about 531 kilohertz. How's it going, my buds? Alrighty, let's go through this real quick. So what I'm working on is the element, periodic table. And I'm looking at all elements as particles, and I'm looking at all particles are matter, and I'm thinking that you could put together a cymatic, and it has a lot to do with everything to do with frequency, and has a lot to do with the cymatic of that frequency in that matter is the bonding agent that makes a element like gold being gold, or an element silver being silver, is because it's got this crystalline lattice, and this lattice is a periodic event, and that's what I'm showing you guys right now. This is what I'm showing you the start of the system that I'm going to make, which is two chambers. They're both vacuum as well as pressure chambers with air. And these are the gauges, and then there's an air pump and a vacuum pump. So I can, right now I'm doing vigorous tests on different things to put inside either the vacuum chamber or the pressure chamber. And I do know the military back in 1920 to 1937, something like that, had used high pressure to increase the voltage, and then your vacuum to create plasma. And that's where we're studying into right now. So hopefully little tests like this brings about new discoveries. And this one here is myself working on Levitation's linear motor and his levitation machine by using or creating a sinusoidal electric river, he called it. And that's using AC, a sine wave, but powered by AC. This here is an event, and this event is allowing the field. The top part of this coil is north facing, and the bottom part of this magnet is south facing. So if I put north facing north, it'll sit there and it'll hold itself up, but no movement. When I put the south going down, not only does it activate it and turn it on, but it also sits there and has a self-exciting event by itself. So let's go ahead and I'm going to go ahead and just stick it in there. I don't have the battery on. And right now we're just going to go ahead and put the battery on it and it'll self-excite itself. And it jumped out. It's like a fish jumping out of its fishbowl. Let's go ahead and elevate it up higher. And a little bit higher. I think what I could use. A little bit taller. I think a little bit more in height, and I think we're fine. All right, let's give it a whirl. That's the wrong pole. Let me flip it over. Now let's turn it on and off. Might be too tall. Yep, so you can see the distance matters in the electromagnetic field. So we will bring it down, bring these back over. Maybe we come up subtly, a piece of cardboard or something. We'll try it one more time. Let's go ahead and stick it in. And we'll put the power on. Nothing. All right, where's that tell? Tells you everything. Let's try it again. Right now I'm adjusting the potentiometer. It seems like it's calming it down, maybe a little too much. So I'm just barely touching the potentiometer. So what I like about it jumping out is you can see that it builds up enough speed to where it starts to just stay up top. So here's where I increase maybe voltage, or I increase or decrease the bottom, because there's an adjustment. I see 3 adjustments here it would take, I mean, to have this. Let's go ahead and do another experiment to get this thing, let's get this thing humming here. So we can turn it on. So now we're going to get it to stay up on itself. Right now it's on. And watch when I bring the magnet by there. Listen. Turned it off. Just turned it back on. So you go too deep, it turns it off. And look, I just turned it back on by sticking the north in there. It's like a switch. See that? Now it's off. On. Sound comes from the coil itself. And right now I'm looking at the frequency. And the frequency says 1.702 kilohertz. And if I put iron in there, it kills it right away. Iron's like the kryptonite to it. So right now, I don't know if you can see. Let me get you near so you can see the light. Every time you see that light go off, you know this thing. So now the light's on. So it's on. So let's listen to it. So the coil itself is making a noise. That's a negative, that's a north, and this is a north. Now if I put the south on there, I don't believe it makes noise. Oh yeah, you hear that, but it turned off. So I turn it around to a north, I can just do this and click it on and see it's on. So we're dealing with the fact that there's an event going on in there, and that event happens to be electromagnetic event. You guys, stay tuned. Peace out, my brohams. Thank you for watching. Leave your comments. It's also, it has everything to do with feedback. Now remember how this coil is. It's a bifilar. The skinny wire here is a feedback. It's feeding back when this thing is turning on and off. So if you think like a sound equipment, if you have a microphone and you have an amplifier and a speaker, you're going to have feedback. And this is where the magic is, my brohams. Stay tuned. Peace out. Leave your comments.